In this video I'll show you how to correctly set the visualization of CodeSys using function and elements already included in the software. For this purpose I've decided to set up this water tank. It has been created with several elements. For example, for the border, I've used the element line, which is under basic and line. I used it moving the 2 points, and I've also increased the thickness of the line going under appearance and line width, increasing it to 5. For the bobber I've used the ellipse, making it as round as possible. For the water I've used several times the rectangle, and I've set the color under colors, normal state, and the frame, which is the border, I've made it blue, and the fill color also blue, and I moved it. And right clicking on it, I've ordered it in the back. And for the pump, I've used this image. I've found it under visualization toolbox, symbols, and I've used the arrow, and I've increased the size. For the whole process, I've decided to create another bow by clicking on Application with a right click, Add Object, and bow. I've decided to call it bow_visualization, using a ladder logic diagram to code my visualization. You can also change it. First, let's set up the valves. To do that, we will use a contact assigned to the original valve in the first program, so into our PLC_PRG. Let's take it. And when the valve is turned on, I've decided to turn on also another variable. Put an output on the same net and give it an easy name, for example the same name of the valve but with state at the end. Remember to put it as a bool type, and I will do the same with the second valve. Once you have created your POW, remember to put it under main task for making it usable during the simulation. Now let's back into the visualization tab and click on the valve, and going on state variables and invisible, put here the name of the variable state for this valve. So now it is into our application, POW visualization, ETV as state. And for the water, we are doing the same, but putting a not before, because we want it to be visible when the variable is on. So let's take the variable and add the not. Now I'll do the same with the top valve and the top water. Let's test it. So first press on P-Start, and the water tank is filling. Click another time on P-Start to see the tank draining water. Okay, now we have to code the water level. For doing that, I'm creating a new network and putting here a CTUD counter by clicking on Insert Empty Block, naming it CTUD, and giving it a easy name. In the issue contact, I'll put the filling valve variable, and in the CD the drain valves variable. For the reset contact I'll put a false because I do not need it, and the same for the load. On PV let's put a big number, for example 1000, because we do not need the boolean output of the counter. So also delete the 3 red question marks. And in CV, let's create a variable for the visualization, for example water level, and remember to use it as a word. But now it cannot work because we need a clock before the 2 inputs. So let's create a net before it with a blink block. For obtaining it, you can go on Library Manager, Add Library, and search for blink, and double click on it. You see this window because the block was already in my library. Now you can put here the name blink. So once obtained the blink block, Put on enable a true contact, and on time 8 and time low a reload time, for example 10 milliseconds. In the output add a coil, and remember to put its contact before CU and CD. And now go back in the visualization tab and set the variables. So click on the water block, go on relative movement, movement top left, on the Y, double click and add the water level variable with a minus before it, because we want it to go up. And we have also to put the same variable into the bobber, but now under absolute movement, movement Y, let's choose the variable and put a minus before it. Now is the moment to start the simulation. So click on Start to see the water level increase. And when the bobber is on the top, it stops. And click another time Start to see your tank draining water. The only thing left to set up is the rotation of the pump. So let's go back editing the POW for the visualization. And do the same as the water level. So create a new network and copy the blink, but now changing its name because we want a different clock. For example, we can now reduce it at 5 milliseconds. Remember also to change the name to the coil. And in a new network, insert an up counter. So let's write here CTU and give it an easy name, for example rotation. And do the same as the water counter. Add the clock contact and the pump. So plc underscore plg dot pump. And in the reset, the emptying valve. Remember to put a big number in the PV and a variable in the CV. So come back to the visualization tab, click on the two rows, and under absolute movement and interior rotation, put the variable of the rotation. And now let's try the whole system. So clicking on the P-start, the water level increases and also the pump is rotating. And by clicking P-start another time, the water level is decreasing and the pump is not rotating. And also the valve is open. In our visualization, there are two main problems. The first is that our water sensors are not working by themselves. And the second one is that our water tank can overflow. To resolve these two problems, we can easily create another POW for keeping everything more organized, but you can also use POW underscore visualization if you prefer. And I'd like to name it POW underscore auto underscore visualization. Now we have to add a contact, set as true, a comparator, which can be found under math operators, and for example now I'm using greater or equal, and a set coil on the output. The first variable of the comparator has to be the water level, and we are setting the bobber analyzer. And we need two of the network like this because we have to do the same process also for the second bobber analyzer. And we need two more of them because we also need to reset the bobber analyzer. So let's change the coil function. And for this we need a less or equal comparator. The four remaining variables, we are obtaining them by simulating the first time, so now I suggest you to put the number that you put in the counter. But before starting the simulation, you have to go on your main program and set the bobber variable as var underscore input. by clicking here and var underscore input. And I suggest you to click on the window and the new vertical tab group, and on the right keep your tank, and on the left put the POW underscore visualization program. Start the simulation. Click on P-Start, and when the water level is at the height that you want it to set the first bubble analyzer, read this number, which now it is 39, a little lower, so I will use 35, and continue the simulation to see what is your level for the Eiger bubble analyzer. And now mine is 314, so I will use 315. Log out from the simulation, go on PO underscore out underscore visualization and put the numbers. So for the GAL-P, which is the top bubble analyzer, I'll put 315 for the greater or equal and 314 for the less or equal, and 35 and 34 for the remaining. Before simulating, remember to put your PO underscore auto underscore visualization under the main task, as you've done with PO underscore visualization. So start the simulation, click on P-Start, and the first bubble analyzer is working. And also the second one. Let's try it in reverse. The first bubble analyzer works, and also the second one. Thank you for watching this video. I hope you understood everything that I said, and bye bye.